speak where this was framed.
I see, and so you got a little bit sawdusty.
Just a little bit. Yeah. Shows up on the black pretty good.
This is gray.
All right, you'll notice in your notes, it's pretty much a blank page. So there's a lot of space for you to do examples. What's a composite figure? The definition.
Find the area of the whole circle and divide it by 2.
Right. All right, let's try this first example. Find the shaded area, which is the whole shape, round to the nearest tenth if necessary, but remember to do that at the end as much as possible. And this one, I put the dashing in there so that you can see how much of a circle is there.
What if it's like 76% of the circle?
Yeah, I guess I should clarify,
Yeah, that's
there's
what,
the center point.
okay, because it kind of looks like an oval, isn't it?
Yeah, it's probably kind of distorted from when I made it on my computer when it comes across to it. Typically, it's gonna be maybe half or a fourth. You don't have to write down as many decimal numbers. I like to keep track by either drawing my shapes or writing out what shape I'm doing. Pi times, what's the radius?
10.
10. So pi times 10 squared, and we're going to take that times a half because we only want half of a circle.
Oh, yeah.
Right?
Okay. So
I'd say that's the most often skipped thing, is getting that you want only half of the circle. So 10 squared is 100. Half of 100 pi is 50 pi. And I'm not going to do the decimal yet. I'm just going to keep 50 pi is the semicircle, the half circle. Then if you wanted to do the rest as a complete trapezoid, what's the formula for a trapezoid? G? Now again, if you want to mix the height up in a different spot, that's fine. Okay, the bases, 20 and 32. The height, how far perpendicular between the parallel bases?
14.
14. And we have to get the 1/2 in there. Half of 14 is 7 times 52 is
364.
364.
Okay, I started off doing like this 1 plus these 2 times height divided by 2.
Okay, so that'd be 52 times 14
It still comes up
divided
the
by
same.
2 should be the same thing, right?
Okay,
Yeah, we
so
should-
I can use
Yeah, we shouldn't get different answers. We're both figuring the area of the same thing. Okay, so then to find the area of the shaded region, you're simply adding those together. Now, can I add 364 and 50 pi and come up with 414 pi? No. Imagine that pi is like an x or a y. You can't combine unless it's like terms. So the only thing you could do is now go to decimal. So go ahead and give me a decimal approximation.
157.07. 08, excuse me.
457, you said?
I said 157.
If you're adding these together, I'd say that's just the pi,
Oh, I was-
50 times pi. Okay, add 364 to that. Add 364 to it.
360. No. Yeah. Stop.
Yeah? But it's probably like 500.
I'm just adding pi is what I'm doing. That's the problem here.
50 times pi maybe, and then add 364. Some of you know what number he's gonna give me, I hope.
You know, just go.
I don't know what it is. 521.1?
LOL.
Did you get there?
Well, let me show you. I was just, okay, so it's 50 times pi plus. There we go. That's.
All right, 521.1. Any question on that problem? Did Zach do something weird or what? No?
Great number.
He did. So you can divide it, and you'll notice on my example, I divided it into a triangle, a rectangle, and a half circle. So again, I just did each part separately. So work on your homework should be shown, right, with pictures there, right, Zach? So we have it all figured out. Okay, next one. That whole shape there. Find this. What's the formula for a parallel? How to divide it by two.
Yeah.
Is it really? Have you ever heard that song before?
Which one?
Build me up, Buttercup.
No, it's not on the
Oh God!
No, I don't think I have.
It's like a 1960s.
That's before me.
Yeah, but it's before us too.
Yeah, way before you. All right, area was 64 square feet. Question on that one? Or did I say 64? 65 is what it's saying, 65. So the parallelogram was just 8 times 5, and the triangle is 1/2, 10 times 5. That making sense? Okay, let's try another one.
These are easy, Miss Frank.
Yay! Good.
Too easy.
Okay, next one.
Maybe.
Maybe you can make it a right triangle.
Well, decide how you want to divide it. Well, draw it in there and then take a look at what measurements are there.
75 minus
Line it up.
365. 37. No, you take 75 minus 337.5.
There you go. Thanks.
Yeah, you're trying to set the right number. Okay, figure out how to divide it and then look for the measure to find the height of the triangle. That would be correct. We know part of it is 22 and a half, but we don't know what that top section is. So use the Pythagorean theorem to find your height. I think everyone's dividing it this way. And the measurements here, if 75 is the total, and this section was 37.5, when you subtract, I think this one is 37.5 also, happened to be divided in half. That could be a height. What would be your base? This one? Yep, you still would have to find what that measurement going up is, no matter if you call it the base or the height. You've got to figure out this measurement. Excuse me? It's 22.5 just up to that intersection point, but I don't know if this top part is the same or not.
No, it's not.
It's not? Okay.
Fit.
So do the Pythagorean theorem to figure out what it is.
My final answer. You got 1,070.
Okay, so the height we wanted was 50.0, you said? Just exactly. All right, so you found the area of this rectangle, 37 and a half times 22 and a half. And then the triangle, I guess let me write down some things here. Rectangle was 37 and a half times 22 and a half.
I did part of it.
And then the triangle was 1/2 of 37 and a half times 50. And then you're adding those two answers together. that sound like what everybody did?
1,781.
1,781.25?
Yep.
Okay, let me show the numbers here in case there was any questions. Added together. I had 0.3 to the nearest tenth. Okay, question on that one? Did you get it right, Lucas? Jacob, how are you doing? Okay.
Let's just take. Actually, let's not.
Find the area of the shaded region.
42.25 pi.
Okay, so you're doing 1/2 of pi r squared. Radius is? How much? 4.5, okay? So 1/2 of 4.5 squared times pi. 4.5 squared must have been like 20.25. And then do half of that, that's where my 10.125 came from. Again, I didn't multiply by pi yet. I'm waiting till the end, so I don't have to write down a bunch of decimals. You might, if you're rounding right away, you're going to be off a little bit more. Okay, when I subtract rather than add, oops, too far again. If I have a delay on it. Okay, so in the end, I have 202.2. And again, a common mistake is subtracting a complete circle. But you really aren't taking a whole circle out of the triangle, you're only taking half. Follow-up questions? Okay, next one. I just keep getting better. Find the shaded area. Can you tell which part's shaded?
Yeah, the circular part.
It's a circle, but not the trapezoid. So there's some little pieces there. Okay, so do you, okay, answer.
You're thirsty.
186.2?
Close enough.
What'd you have?
186.16.
Well,
Same.
nearest tenth, you shouldn't have two decimal places.
That's true. So it means, yeah, then I'm right.
Okay, questions? How many got that right before I showed it? All right.
Well,
hands down.
technically.
And Jake's working on catching up the last couple of days that he was gone. Okay? All right, next shaded region. And the shaded, this one's kind of hard to see. The shaded is this part on each of them. Sounds like they got it. Area of the circle was 9 pi, and the area of the rhombus was 18. So you subtract.
Super
Okay.
I go next.
All right, next one is, we're needing to make these
Stop.
heart-shaped
Miss Frank, let me
things.
explain. Can't we just find the area of one circle?
So you see that as two half circles?
Mm-hmm. So just
Okay.
find what's one.
Could do that, right? You don't have to do half a circle and half a circle. You can mentally think, okay, together that's one circle, and then a
Square.
square because of the right angle
I'll work
involved.
it out on the board.
Okay. This square, okay, this square was 3 by 3,
9.
so that was 9 square inches. And then the two circles,
3 times
the two circles together would be a circle with a diameter of
3.
3. So the radius was
1.5.
1.5. So the area of the circle is pi times 1.5 squared. Is that like 2.25 pi? Is that right? Okay, so we have to take that and add 9 onto it. And then give me a decimal. What's 2.25 pi plus 9?
Oh, you want 16.07.
16.07 would be more accurate than just 0.1 rounded. Okay, so what did we just find?
You found the area of one of those hearts.
Okay. Question on the area of one of those hearts.
Then you times it by 65.
Okay, multiply by 65. And we get,
I have the answer on my calculator.
I don't.
4, 6.
So 1046, 1046.5
Then you divide it by
square
6.
inches. Is that the right number? Not the right number? Okay, 16.07 times 65. 44 I have. 1044.55.
How did you get that wrong?
Nice.
Abby.
Okay,
Yes, your
so
genetics.
now what do we do to figure out how much dye? It doesn't say 2 ounces of dye for every square inch. It says for every 6 square inches, we need 2 ounces of dye. So how many 6 square inches? So divide it by 6.
174.09.
Okay, so that's like how many groups we need, and we need 2 ounces of dye for each one.
So you divide it by 18.
We need 2 ounces of dye for each of those.
Divide by 9. Times it by 2.
Times it by 2. 348.18, and let's see, how much dye?
Ounces of dye.
So we need, 348.2 ounces of dye.
So 348.
Round it up, otherwise that last heart's not gonna get as red as you need it to be. So you can't round down. When you're doing things like having enough material to make something, you can't just leave off the extra.
Well, what if they only sell whole? Like,
Yeah, depending. Now, I've got a different number. Oh, wait a second. At the end, 348 okay, I've got it. 348.18 batches of dye, or ounces of dye, okay? So if they only sold it in ounce bottles, you'd have to buy 349, and you'd have just a little extra. Yeah, you'd have to round up totally instead of down. All right, understand that little bit more complicated one?
Yeah. Perfecto.
Okay, here's a little bit different type. This is a really odd shape. It's got a lot of curves, so we probably can't make a good representation just using triangles and
Use
squares, but we
squares.
can come close, okay? So we can divide this up, and I know this type of problem is a lot easier if you have it on paper, but where can we divide it? You wanted to work it, you want to draw where to divide it? We're going to try and divide it into like rectangles, trapezoids, triangles, whatever color you want. You're dividing it into things we could easily find the area of.
Oh, I can just do this whole big one.
Okay? So that whole thing would be 4 square units.
good job, there's
Okay, now how about the other parts?
triangle.
Triangles,
Oh, we can make this a big triangle.
big triangle, okay? Keep going, you gotta get everything,
This is another big triangle.
okay?
This is another. Can we just make it a triangle?
Right
Let's
triangle.
see.
Oh, yeah.
One.
Oh, we can make that a trapezoid. Make that a triangle.
Okay. All right, he's making some of them a little bit more detailed maybe than what I was even going to do. So, okay, let's, go ahead, thank you. And we'll do some numbers. So initially, he did this middle part. What's the area of that? So 2 by 2. 4 for that. Then he did a triangle over here.
2,
which would be a base of 2 and a height of 1.
1.
Triangle, 1 for that. Same kind of thing down here.
1.
1 for that. I thought that you were going to maybe go all the way to the top here. Could do that, maybe to the top this way.
1.
That would be 1. It has a little extra. Maybe that extra will take care of some of the part that I left out over here. So sometimes you want to go inside, sometimes you want to go outside of the shape to allow for those differences. Okay, now we've got this part. He was thinking trapezoid. Can we just go make it easy? Let's go square there. So I've got a trapezoid with a base of 2 and a base of 1 and a height of 1. So 3 times 1, so that'd be 1.5 for that. So it looks like we're coming up with 4, 5,
8.5.
6, 7, 8.5.
Yo, well.
And on those, I will give you a little bit of variation. I think I said from 8 to 9. I don't really think that in your estimating, you're going to or need to go any more exact than a half. If you're dividing it into something, you're probably not really just estimating. You're going a little bit more detail. Okay? All right, let's try another irregular shape here.
Can I do this?
Kate.
You're up there already. Anyone else? Okay, Michael wants to do a smartboard activity. Hey, while he's getting up here, think, how would you suggest he divides that up so we can find the areas?
There's some
of it?
squares in there.
Okay, thank you.
All right.
No. We'll do a
So
rectangle.
do you think how you would divide it?
A rectangle.
6.
Okay.
Thank you.
6 for that. Okay.
And we could do a big triangle. Now we couldn't, could we?
Maybe a trapezoid would be better.
Mr. Call Michael.
Go diagonal to the top of that.
Like this. No,
That's it.
Let's say eraser. Not tech savvy. Like
Not
that.
Yeah.
Sadly. Whatever.
Either that or diagonal on that last one.
And then we could do another trapezoid. Then we could do a big triangle. Then we could do another trapezoid.
All right, so finish totaling.
Calculating.
Okay.
Right, copy math.
One, I can't tell. So we're gonna do, okay, so that'd be, we're gonna say 2 for that one.
Big.
We're gonna say 1.5. We're gonna say 2.5. So 4, 10, 13.5.
Okay, and as you step away, we'll look and see if we think that those were right estimates or not. Thank you.
That's pretty good.
Okay, now you kind of question this 2 up here. It was a triangle, 2 was the base and 2 was the height. 2 times 2 is 4, but a triangle's half of that. So his 2 is
I
correct.
realized that.
Okay, trapezoid, trapezoid. Do you think his estimates are good?
Yeah.
A little low or a little high?
Muy
Did he
bueno.
leave more out or add more in? I don't know. He did pretty good, I think. He's got extra here, but he probably left out some when he made that triangle. So what did I have? I had 13 to 14. So he's right in the middle. All right, so those will be easier on paper, graph paper. I'm sure there's probably some markings in your textbook where someone else did it, but erase those and start again. Okay.
Keep Malali.
Cake,
You wanna do
cake,
cake?
cake, 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 cake,
Not really?
cake, cake, cake. Cake.
All right, now each of you think, how would you divide it up? Good. Just pick up a marker and see how you would divide it. This one's kind of different, isn't it? Each of you decided how you would divide it?
Kelsey Ruth.
She's got a little triangle and a rectangle.
Sorry, Miss Frank.
Being rude to who you asked.
Kate, I apologize.
How would you suggest she leave the next
So or another square.
You can make it a trapezoid on that one sticky outy thingy with the little square on it.
A vertical trapezoid or horizontal trapezoid, which way?
Up there.
Vertical with the pointy at top.
So you're talking here,
Yep.
Yeah.
that way? Okay. Now,
Oh,
these
yeah.
triangles, do the triangles have to be right triangles?
Is that
Could she look at this as an obtuse triangle?
Yeah. Sure.
What would be the base and height of it?
3, maybe. Yeah, 3.
A 3 probably wouldn't
For
be
the-
the base. The base would probably be these 2,
Oh, true. Yeah.
and then
two,
the height
two.
would be 1 unit. So it's up to you if you want to do it that way or not.
That's how I would do it, Kate. If that says anything.
Okay, so what's, yeah, and then just go diagonal all the way to there. So are we under or over?
Under.
Think we're under?
By far.
Okay, so what are our areas? What was this last one here, this obtuse triangle?
1.5.
Base was 2, height was 1.
1.5.
That's not 1.5.
Yeah.
1.
The base is 2 and the height is 1 and it's a triangle, wouldn't that be 1 total? So 1 for that,
Wait, no. For a triangle, 2 plus
2
times
times height.
1.
Okay, trapezoid,
Trapezoid, 1.5.
1.5.
C.
Rectangle,
2.5.
2.
2.
Oh, you know, I was actually thinking that was an add-on to or something.
And then she had this, just
Half.
half. So what are you getting total?
5.
5? Okay, I don't remember what I had. And I came up with, oh, 5.
Oh, she's exactly right.
Okay, so we did composite shapes. How would you break this one up?
Circle, triangle, and rectangle.
Now, I wouldn't do a whole circle,
I meant
half a
circle,
circle, rectangle, triangle. How about this one?
You could do
Rectangle.
trapezoid, rectangle.
Okay, rectangle could be the great big thing, and then subtract the trapezoid.
Oh.
I had never
Or you could
actually-
do this rectangle, and then I suppose, if we can figure out the measurements, you could do maybe this as a trapezoid and that as a trapezoid. But the subtraction idea, and then the story type problem, this is kind of like the die one that we did. Okay. All right, so I just thought I'd do some examples, and then we should have some time to start our projects and work on some homework. So let me get the assignment. Stop this
Kelsey
right
needs
now.
to do one.